unlocking the universe of knowledge. Welcome to Astronova. Ever wondered how Netflix suggests movies you might like, or how self-driving cars navigate through traffic? These are examples of machine learning in action. We live in a world where data is being generated at a staggering pace each day. But what if we could make sense of this data, find patterns, make predictions, and even make decisions? That's where machine learning comes in. It's a type of artificial intelligence that focuses on building computer systems that learn from data. It's like teaching a child how to ride a bike, but in this case, the child is a computer system, and the bike is data. Machine learning algorithms are trained to find patterns and relationships in data, enabling software applications to improve their performance over time. It's the secret sauce behind many of the technologies we use daily, from email filtering to voice recognition, and it's becoming increasingly important in our data-driven world. So, let's dive deeper into this fascinating world of machine learning. Did you know machine learning isn't a one-size-fits-all solution? There are different types, each with its unique approach to learning from data. In the world of machine learning, there are four main categories that shape how we teach machines to learn, think, and adapt. These are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Let's start with supervised learning. Picture a child learning to identify animals. You show them a picture of a cat and say, "This is a cat." You're providing them with labeled data. Supervised learning works in a similar way. It uses labeled data where the correct answers are already known to predict future outcomes. It's like having a teacher guiding the learning process. Next, we have unsupervised learning. In this case, think of a child left in a room full of toys. They start sorting them based on shape, color, or size. There's no one to guide them. They're learning by finding patterns and structures in the data. Unsupervised learning algorithms sift through unlabeled data, discovering hidden patterns and learning from them. Thirdly, we have semi-supervised learning. This is a blend of the first two types. It uses a small amount of labeled data and a large amount of unlabeled data. It's like learning to identify animals by being shown a few examples and then figuring out the rest on your own. Lastly, we have reinforcement learning. This takes inspiration from how we learn through trial and error. The algorithm learns to perform an action from positive or negative feedback. Think of it as training a dog. You reward it when it obeys a command and ignore or mildly reprimand it when it doesn't. Each type of machine learning has its strengths and weaknesses, and the choice depends on the problem at hand, the available data, and the desired outcome. Now that we know the categories, let's explore each one in detail. Imagine having a tutor while learning something new. That's how supervised machine learning works. This branch of machine learning is like having a private tutor guiding you through a subject, providing you with correct answers and explanations. In supervised machine learning, we start with a set of data called training data. This data is already labeled with the correct answers or outcomes. It's similar to a teacher providing students with a textbook filled with solved examples to learn from. The machine learning algorithm uses this training data to learn patterns and relationships. For instance, let's consider a simple scenario. You want to teach a machine to differentiate between pictures of cats and dogs. We provide the algorithm with a bunch of pictures, each labeled as cat or dog. The algorithm learns from these examples. It identifies the unique features in each image that make a cat and a dog a dog. Once it's learned these patterns, it can accurately classify new unseen images. Supervised machine learning is like a student studying for a test. The student learns from the textbook, understands the concepts, and then applies this knowledge to answer questions in the exam. Similarly, once the algorithm is trained, it can predict outcomes for new data it's never seen before. However, it's important to note that the quality of learning heavily depends on the quality of training data. If the training data is inaccurate or biased, the algorithm will learn the wrong patterns, leading to incorrect predictions. So, supervised machine learning is a powerful tool, but it comes with its own set of challenges. It requires a good amount of labeled data, and the accuracy of predictions heavily depends on the quality of this data. Now, what if there's no tutor? Enter unsupervised machine learning. In unsupervised machine learning, the system learns all by itself, without any labels. Imagine being in a dark room filled with different objects. You don't know what these objects are, but you can feel them, touch them, and recognize patterns. You can group similar objects based on size or shape, or any other characteristic you can perceive. This is the essence of unsupervised machine learning. Unsupervised learning is like exploration. The machine is given a dataset without any specific instructions or labels. It's like handing over a treasure chest to an adventurer without a map. The machine sifts through this data and using complex algorithms identifies patterns, clusters, and relationships. Let's consider an example. Suppose we have a dataset of news articles. We don't provide any labels like sports, politics, or entertainment. The unsupervised learning algorithm would analyze these articles, look for common themes or words, and might group them into categories such as international news, local events, or celebrity gossip. It might not be perfect, but it's a start. But why do we need unsupervised learning? Well, in many real-world scenarios, we don't have neatly labeled data. For instance, let's say we want to analyze customer behavior in a supermarket. There are countless variables at play: the age of the customer, the items they buy, the time of day they shop, and so on. With unsupervised learning, we can identify patterns and trends that might not be immediately apparent. Unsupervised learning is a fascinating field with huge potential. It's like a detective piecing together clues from a crime scene. It's not easy, but the results can be incredibly rewarding. But what if we mix both these methods? That's where semi-supervised learning comes in. Sometimes we have a bit of both, labeled and unlabeled data. This is where semi-supervised learning shines. Imagine a scenario where you have a large data set, but only a small portion of it is labeled. Labeling data can be time-consuming and costly, so it's not always feasible to label everything. That's where semi-supervised learning comes to our rescue. Semi-supervised learning is a middle ground between supervised and unsupervised learning. It utilizes both labeled and unlabeled data during the training process. The concept behind it is pretty straightforward. It uses a small amount of labeled data to guide the learning process with a larger pool of unlabeled data. Picture this as trying to solve a jigsaw puzzle with just a few pieces already placed correctly. These few pieces serve as a guide, helping you to fit the rest of the pieces, which are the unlabeled data points. By doing this, the algorithm is able to make better predictions and learn more about the underlying structure of the data. Now you might be wondering, why not just use supervised or unsupervised learning? Well, semi-supervised learning brings the best of both worlds. It utilizes the power of supervised learning's predictive capabilities and the exploratory nature of unsupervised learning. This way, it can work with large amounts of data without requiring extensive labeling, yet still deliver reliable results. In real-world applications, semi-supervised learning can be seen in many areas, like in text and web data analysis, where labeling all the data is almost impossible due to the sheer volume. It's also used in image and speech recognition tasks, where labeled data can be hard to come by. So remember, when you have a mix of labeled and unlabeled data, don't fret. Semi-supervised learning could be your best bet to navigate this tricky terrain. Finally, let's look at a different way machines can learn, through reinforcement learning. Scene script. Think of a child learning to walk, stumbles, falls, but gets up again. That's akin to reinforcement learning. Imagine the whole process of learning. It's not a straight line, is it? It's a series of trials and errors, of rewards and punishments, of stumbles, falls, and getting back up again. This, in essence, is the idea behind reinforcement learning, the fourth type of machine learning we're exploring today. In reinforcement learning, an agent, say, a software bot, interacts with its environment, making decisions and learning from the consequences of those decisions. It's a bit like navigating a maze. The agent doesn't have a map, but it learns by exploring, bumping into walls, finding dead ends, and discovering the path that leads to the exit. The key to reinforcement learning is the concept of rewards and punishments. The agent gets a reward when it makes a good decision, and a punishment when it makes a bad one. This could be as simple as gaining a point for a correct move and losing a point for a wrong one. Over time, the agent learns to maximize its total reward by choosing the best actions. Now, this process isn't quick or easy. It involves a lot of trial and error, a lot of stumbling and falling, just like that child learning to walk. But with each fall, the agent learns something new, and with each step, it gets closer to its goal. A prime example of reinforcement learning in action is in the world of gaming, where software agents learn to play and win games by constantly interacting with the gaming environment, learning from their mistakes, and improving their strategies. But it's not just games. Reinforcement learning has wide-ranging applications, from self-driving cars, learning to navigate traffic, to recommendation systems, learning to suggest the right products, to robots learning to perform complex tasks. Knowing the types of machine learning lets now understand how to choose and build the right machine learning model. Choosing and building the right machine learning model is like finding the right key for a lock. It's a process that requires a clear understanding of the problem at hand and the data you're working with. Firstly, you need to understand the business problem. Is it a prediction task, a classification task, or perhaps a clustering task? Each type of problem may require a different type of machine learning model. Next, you need to define your success criteria. What does good look like for your model? Is it accuracy, precision, recall, or maybe a balance of all three? By defining your success criteria, you can guide your model towards the desired outcome. Then comes the selection of the appropriate algorithm. This depends on the type of problem, the amount of data, and the features of the data. Among the various algorithms, you might opt for a linear regression model for a simple prediction task, or a neural network for a complex classification problem. Finally, you must follow a 7-step plan for developing your model. These steps include gathering and preparing the data, choosing and training the model, evaluating the model, tuning the model, and finally, deploying the model. Remember, building a machine learning model is an iterative process. You may need to go back and forth between these steps, tweaking and refining your model until it meets your success criteria. This process might seem complex, but it's worth the effort. With the right model, you can unlock numerous applications of machine learning. From recommendation engines to healthcare, machine learning is revolutionizing every industry. Its footprint is evident across sectors, weaving a web of intelligent systems that learn, adapt, and innovate. Take recommendation engines, for instance. Machine learning algorithms sift through vast amounts of data, identifying patterns and preferences to make accurate predictions. They suggest books you might enjoy, movies you'd love, or even your next favorite song. In healthcare, machine learning is a lifesaver, quite literally. From predicting potential health risks to aiding in complicated diagnoses, it's transforming the way we approach medicine and patient care. In the automotive industry, the dream of self-driving cars is becoming a reality, thanks to machine learning. It's the brain behind these autonomous vehicles, learning from millions of miles of human driving, adapting to various road conditions, and ensuring a safe journey. But the story of machine learning is far from over. Its future is as exciting as its present, if not more. The potential applications are limitless. Imagine a world where machine learning algorithms predict natural disasters, saving countless lives. Or consider smart homes that adapt to your lifestyle, conserving energy and increasing comfort. Machine learning is also set to revolutionize education. Personalized learning experiences, based on a student's strengths and weaknesses, could transform the way we learn, making education more effective and engaging. In the world of finance, machine learning could enhance fraud detection, making transactions safer and more secure. The potential is endless, and as technology evolves, so too will the applications of machine learning. It's a thrilling ride into the future, one that promises to be transformative and empowering. So, as we delve deeper into the digital age, machine learning continues to be a key driver in this journey, making our lives easier and more efficient. It's not just a tool, but a companion, guiding us towards a smarter, more connected world. Before we wrap up, we have something exciting for you. If you're eager to learn more about machine learning, or if you wish to delve deeper into this fascinating world, we've got you covered. Astronova, our dedicated platform, is brimming with in-depth guides, comprehensive tutorials, and engaging content on machine learning, and a plethora of other exciting topics. Whether you're a beginner dipping your toes into the world of machine learning, or an expert looking to enhance your knowledge, Astronova is the destination for you. Visit us at www.astronova.com and embark on a journey of learning and exploration. Our content is designed to make complex topics, like machine learning, accessible and engaging. So don't just stop here, there's a whole universe of knowledge waiting for you at Astronova. Remember, the more you learn, the more you grow. So, keep that curiosity alive, keep exploring, and let's learn together. Visit www.astronova.com today. If you enjoyed this video and found it helpful, we've got plenty more where that came from. Don't forget to hit the subscribe button to stay tuned for more informative videos like this. We're constantly updating our content to bring you the latest insights and tutorials on machine learning and other exciting topics. Your subscription helps us to continue creating high-quality educational videos for everyone. So click that subscribe button, ring the notification bell, and become a part of our growing community of learners. Don't miss out on any updates. Stay connected, stay curious, and let's continue this journey of learning together. Thank you for watching, and remember, never stop learning.